Welcome to Structural Patterns. In this video, we are looking at the adapter pattern, a technique for making two pieces of code work together even when their interfaces do not match. By the end, you will be able to spot it in a real code base, implement a minimal version yourself, and know when it is the right tool versus when it is overkill. Here is a situation every developer eventually hits. You have written code that calls, say, a method named render, and it expects an object with exactly that shape. Then you bring in a third-party library that does exactly what you need, but its method is called draw. You cannot modify the library, and changing your interface would break every existing caller. You are stuck with two things that should work together but simply cannot speak the same language. Think about a travel power adapter. Your laptop charger is perfectly good, and the European wall socket is perfectly good, but their shapes are incompatible. You do not redesign your charger, and you do not rewire the hotel wall. You clip a small adapter between them. That adapter converts one interface into the other without touching either original. That is exactly what the adapter pattern does in code. The pattern has four named roles. The target is the interface your existing client code is written against. It defines the method names the client calls. The adaptee is the class you want to reuse but whose interface is different. The adapter is the glue. It implements the target so the client is happy, and internally it delegates to the adaptee to do the real work. The client never knows the adaptee exists. There are two forms, the object adapter, which holds the adaptee by composition, and the class adapter, which inherits from it. Composition is almost always preferred in TypeScript. Let us walk through this top to bottom. First, the target interface renderer declares one method, render, which takes a string. That is what the client is written against. Next, legacy printer is the adaptee, a pre-existing class we cannot change. It does the same job but through a method called printFormatted. The printer adapter is the heart of the pattern. It implements renderer, so it satisfies the target interface, and it holds a private reference to a legacy printer instance. That is the composition. Inside render, it simply translates the call by forwarding to printFormatted. The client function displayMessage only knows about renderer. It calls render and has no idea a legacy printer is involved. At the bottom, we wire everything together. Create the legacy object, wrap it in the adapter, and pass the adapter to the client. At runtime, the flow is straightforward. The client calls render on what it thinks is a renderer. The adapter intercepts that call, translates it, reordering arguments, renaming or reformatting as needed, and forwards it to the adaptee. The key consequence is decoupling. The client never imports or references the adaptee, so you can swap the underlying implementation by writing a different adapter without touching the client at all. The trade-off is honest. You have introduced an extra class and one more layer of indirection, so if the interfaces were almost identical to begin with, this may be more ceremony than it is worth. Reach for the adapter when you genuinely cannot touch one or both sides of the interface mismatch. Classic cases are third-party libraries, legacy modules, or external APIs that change independently of your code. Skip it when you control both sides and could simply rename the method, or when a tiny wrapper function solves the problem in 3 lines with no ceremony. Also, watch out for translation logic so complex, it smells like a facade instead. If you are re-implementing significant behavior rather than just renaming a call, that is a different pattern. To wrap up, the adapter pattern is your go-to tool whenever two pieces of code need to cooperate but speak different interface languages and you cannot change either one. Remember the 3 roles, target, adaptee, and adapter, and favor composition over inheritance when you implement it. It is a genuinely useful pattern, but apply it deliberately. If you own both sides of the mismatch, the simplest fix is usually just to change the interface directly.